All right, welcome to the first talk of the first session of the third DieHard Speaker Diarization Challenge workshop. It would have been nice to see everybody in person, but given the year we just had, I guess this will have to do. In terms of structure of this talk, I'll start briefly with a little bit of background on what led to DieHard and what happened in the first two DieHard challenges. Then proceed to talk for a little bit about the DieHard 3 tasks and dataset, the baseline system that was released for DieHard 3, as well as its results on that dataset, and then finish up with a discussion from a high-level perspective of the final leaderboards this year and some of the future plans for DieHard. So first, a little history of DieHard. Let's go back here actually to 2002. 2002 to 2009, NIST ran an evaluation series, the Rich Transcription evaluation series, that among other things had a task focusing on speaker diarization, or who spoke when in a recording. Early evaluations in this series focused on diarization of conversational telephone speech and broadcast news, though later evaluations focused on a meeting room scenario similar to that in AMI. There are two main contributions from the RT series. First, it led to substantial improvements for diarization and of meeting speech in particular. And it introduced the diarization error rate metric, which remains the principal evaluation metric within this field. Following the end of the RT series in 2009, there was a nearly 10-year period, 2009 to 2017, which for want of a better term, I've deemed the wilderness years, where work on diarization continued in many groups in industry and academia, and there were many clear advances often happening in tandem with speaker recognition, but there were no major evaluations of a diarization component, which led to, unfortunately, a fragmentation of the research community where different groups would focus on different domains or data sets, sometimes with inconsistent evaluation procedures, which made it very difficult to gauge progress that was happening during this 8-year stretch. This is the backdrop for the 2017 JSON workshop, and emerging from that workshop, DieHard 1. DieHard 1 ran spring of 2018 with results reported at Interspeech that fall. It looked at diarization from the perspective of single channel speaker diarization from 10 fairly diverse domains. Systems were evaluated on two tracks. There was track 1, which looked into diarization starting from a reference speech segmentation, and track 2, where systems just get the audio and have to do their own segmentation, diarization from scratch. The primary evaluation metric was diarization error rate, and 13 teams submitted systems, with track 1 run by Johns Hopkins and the best performing system for track 2 coming from Brunel University of Technology. This was followed 1 year later by DieHard 2, which ran spring and summer 2019. Results presented at an Interspeech special session that fall. DieHard 2 maintained the single channel tracks from DieHard 1, with the addition of vastly improved annotation and some additional data for certain domains. It added 2 tracks evaluating multi-channel far-field diarization using the Chime 5 dinner party corpus. And for the first time, we supplied a baseline system and results for all tracks. 21 teams submitted systems, with all 4 tracks being won by Brunel University of Technology. If you look in the bottom left-hand corner of this slide, there is a table that presents for each track the diarization error rate from the baseline system and the diarization error rate from Brunel's system. In all cases, Brunel's system is far as a massive improvement, but particularly for tracks 2 and 4, which are also testing speech activity detection. I'd also be remiss if I didn't at this point mention that while DieHard was the first of the modern challenges with diarization components, there are 4 other recent challenges that include diarization. Chime 6 included diarization in track 2. Fearless Steps 1 and 2 looked at massively multi-channel diarization from Apollo 11 mission recordings. The most recent Vox SRC looked at diarization of multi-speaker YouTube videos. And Iberspeech has looked at diarization of television broadcasts and of diarization across a lifetime. Moving on to this year's evaluation, there are a few key changes from going from DIHARD 2 to DIHARD 3. One, we dropped the multi-channel diarization condition, and instead you see QIIME 6 for results on that data. We also dropped the child language domain. This is the seedlings data. This was done due to licensing restrictions in that data that made it difficult to distribute. We did add additional data for the clinical interview domain, and we did add a new domain to make up for the loss of the child language data. This is the conversational telephone speech domain, which consists of recordings of phone calls that were originally collected during Fisher English, but were never previously exposed. We also, for the first time, collaborated with NIST via their Open SAT evaluation series and use their platform, their evaluation platform, for all activities. And in the future, we hope for even closer integration. The task, as always, is for each recording to determine how many speakers are present, and for each speaker, identify all the corresponding speech segments. There are two tracks: diarization from a reference set, where the systems provided with the reference speech segmentation, and track 2, diarization from scratch, where the system is responsible for producing its own segmentation from the raw audio. These are identical to tracks 1 and 2 in the previous DIHARDs. We evaluate systems using two metrics: diarization error rate and DIHARD error rate. Diarization error rate is the sum of three sources of error: misspeech, false alarm speech, and speaker attribution errors, and it's computing using no forgiveness collars and explicit scoring of overlap speech. This is the primary metric. It's the metric that's used in all the rankings, and it's the metric I'm going to focus on throughout the rest of this talk, simply due to the lack of space and time. We also did look at a secondary metric, DIHARD error rate, which was introduced originally in DIHARD 2. For this metric, reference speaker and system speakers are optimally paired, and then DIHARD index for each pairing is computed, and DIHARD error rate is simply 1 minus the average of these indices. Typically, it's higher than DER. Sometimes it can be much, much higher. No training data was distributed. However, participants are free to use any public and or proprietary data. In the case where proprietary data is, they are required to adequately document this in the system description they submit. In practice, most teams have used some combination of Voxlet 1 and 2 and or Mozilla Common Voice. The development, we do distribute a development set that closely mirrors the evaluation set. For development and evaluation sets, you're looking at 5 to 10 minute duration recordings from 11 different conversational domains, with at least 2 hours of audio in each domain, and the majority of that data was segmented manually and quite painfully, in some cases up to 35 times real-time annotation rates for DIHARD 2. Annotations for data that's new this year were obtained by forced alignment of turn-level transcripts. And these domains range from the trivial audiobooks, where you have a single speaker, to two-party interactions such as these clinical interviews, broadcast interviews, or map tasks, and social linguistic interviews, to massively multi-party interactions as emerge in courtroom proceedings, goal-directed meetings, speech in restaurants, and web videos. For the first time this year, we have a data set which is not balanced across each domain. 2 domains, conversational telephone speech and clinical interviews, have rather more data than the others. Due to this and concern over those domains dominating the evaluation metrics, we define 2 separate partitions for the evaluation set: a core evaluation set, which is balanced so that each domain has roughly the same duration of audio, and a full evaluation set that uses all the available audio as really being distributed just as a service to participants. The table at the bottom of the slide gives a breakdown of the duration, percentage speech, and percentage overlap speech for each partition of each set. As you can see, the distributions are roughly equal between the core and full partitions within each set. This next slide gives the same breakdown, but on a per domain basis for the core development set. This is mainly to give yet another indicator of how much variation there is across domains. So the number of speakers, the mean number of speakers per recording, ranges from 1 in the case of the monologues, the audiobooks, upwards of 7 for restaurant speech. And the percentage overlap speech ranges from 0% or single digits all the way up to 20% for restaurant speech, meeting speech, and web videos. And if not depicted here are these is the same breakdown for the full partition, development set, and core full partitions and evaluation set, but they're roughly the same. As with last year, we released a baseline system this year. It was based on Leap Lab submission to DIHARD 2. This is a very conventional architecture. There, for instance, there's nothing end-to-end about it. Recordings are divided into short overlapping segments. X factors are extracted for each segment. PLDA scoring is applied to the X factors, and then the output of PLDA scoring is input to agglomerative hierarchical clustering to do a first pass segmentation. This first pass segmentation is then refined using a VB-HMM segmentation step. All baseline components, as well as the recipes for producing the official results, are distributed via GitHub. And I really want to just acknowledge here most profusely all the contributions from Prachi, Venkat, and Rajat for all their hard work training and testing these systems. The speech activity detection module is based on the Kali Aspire recipe. It's a TDN SAD model with 5 TDN layers and 2 statistics pooling layers. And the output of that neural network is smoothed using an HMM with constraints on minimum speech and minimum non-speech durations. It was trained using the entirety of the DIHARD 2 development data. The X factor extraction recipe is fairly generic. 512 dimensional X factors extracted from overlapping 1.5 second segments, centered and whitened using the DIHARD 3 development and evaluation set statistics, then link normalized, and this was trained using Foxlet 1 and 2 with data augmentation. There's nothing particularly unusual about the PLDA scoring approach either. X factors were scored with a Gaussian PLDA model, and then subjected to cluster of agglomerative hierarchical clustering. The stopping criterion for HC was tuned using the development set, and the PLDA model was trained using Foxlib 1 and 2. And then the output of this initial segmentation set, the 8 agglomerative hierarchical clustering, was then used to initialize VB-HMM using operating on 24-dimensional MFCCs extracted every 10 milliseconds. The UBM and total variability matrix for VB-HMM were trained using the same data as the X factor extractor, and posterior scaling was applied to discourage some frequent speaker transitions. VB-HMMs run for 1 iteration. Results of that baseline system for track 1 and for track 2 evaluation set are depicted in these 2 tables. You should really focus on the rows where VB-HMM is yes, particularly for the core partitions, as the core partitions most closely match the evaluation conditions in DIHARDs 1 and 2. For the core evaluation set, the baseline achieves 20.65% diarization error rate, and for the on track 1, and for track 2, 27.34% DER. So that was the baseline system. I'm going to move on to give a discussion of the results from this year's challenge. 23 teams submitted systems, 23 to track 1 and 14 to track 2. Participation spanned 10 countries and 3 continents. And actually, despite everything that happened this year, despite COVID, despite our own delays, this is a slight improvement over DIHARD 2, where we had 21 teams submit. Final leaderboards are available online right now at the OpenSAT website, and these will be updated in early February with links to the system descriptions and full team names. Team names are currently anonymized for some teams. In this next slide, I am presenting a statistical summary of the final leaderboards as you would see on that website. So these are box plots of diarization error rate and Jacquard error rate for each partition of the evaluation set for each track. As I said, I'm going to focus for a reason of time on diarization error rate. If we look at track 1, the median diarization error rate for the core evaluation set is 18.66%, and the median for the full set is 17.26%. The best performing system achieved 13.45% for the core partition, and 11.3% for the full partition. Both of these are improvements over the baseline of 20.65% for core and 19.25 for full. And there's a similar pattern of results, almost basically identical pattern of results for track 2. All the numbers are just shifted upwards by about 6 or 7% due to the additional difficulty of having to also produce a speech segmentation. This next slide goes into rather more detail. This is a breakdown of diarization error rate by domain on the core evaluation set. The leftmost item on this box plot is just reproducing the overall diarization error rate that you saw on the previous slide for sake of comparison. And then for each of the domains, these have been ordered in ascending order of median DER. So there are 3 domains out here that are clear outliers in terms of difficulty: meeting speech, web video, and conversations in restaurants. And then audiobooks is clearly extremely easy. There's a single speaker. It's fairly trivial unless something really goes wrong. I don't know what happened with this entry, for instance. And then in between, you have this continuum of difficulties. There's a large number of domains where median diarization error rate is somewhere between 5 and 15%. And it's the exact same plot for the core eval set for track 2. It's pretty much the same pattern, just everything's shifted upwards, maybe 6 or 7%. There's a slight change in the ordering of which domain is hardest, and there's some slight changes here in terms of this middle set of domains. But it's very much a similar pattern overall. I'm also going to take a slide to present the change in best diarization error rate for each track over time on the core evaluation set. The reason for this is that we've been using some of the same data in DIHARD since DIHARD 1, and DIHARD 2 and DIHARD 3 not only share a large amount of data, but a large amount of the annotation. So there was some worry at the end of the last challenge that this data set might be on its last legs, and we have to start worrying about people tuning to error. So it was comforting to see steady improvements over the course of the challenge. Pretty clearly, this data set maybe only has a couple more years of life left, but it is nice to know there is still some headroom there. So I'm actually a little bit ahead of where I was planning to be this time to talk, but I'll just move on to final remarks. So I really want to just focus on some of our plans for the next few months and then longer term. So in terms of media plans, next week we intend to release the evaluation key to participants. Hopefully this is next week. LDC asked for me to update the JARTech of a couple pieces of information. If I can get that done Sunday, then hopefully that means everybody submitted a system description will be able to download the updated evaluation release at that point. Early February, we're hoping to publish system descriptions to the leaderboards. This is pending everybody getting their description into us at the end of January. But if that happens and we can sort through them in the first couple weeks of February, we're going to have NIST post links from each leaderboard entry to the corresponding system description. We also will be releasing full challenge results as Nodo. So this is all submissions as well as metadata and the output of DScore on a per file and per domain basis. The intent is for this data to support work on system combination methods, such as overlap, and on alternative metrics or evaluation methodologies, because it's pretty clear diarization error rate is not the end-all be-all. It is a convenient metric that has been useful, but it has some glaring problems. And we very much want to encourage people to work on alternative metrics or approaches to applying diarization error rate. Slightly longer term, hopefully by May, publication of the development evaluation sets in the LDC catalog, and also to finally finish publication of DIHARD 2. This was derailed initially by some licensing issues, then COVID, and then just so much time had lapsed that we didn't really have time to take away from other activities to finish the publication. But that is on my to-do list and at the very top. Somewhat longer term, future diehards will be occurring every 2 years. The yearly schedule has just been too grueling and has left insufficient time for proper post challenge activities, summarization of what happened in each challenge, getting results published in a timely manner, and just doing our own research. So we will be moving to an every 2 year schedule with the next diehard currently scheduled for 2022. And if you want any additional details about the challenge design, the baselines, or the leaderboards, just go to the official website. It's all there. If you have questions that aren't answered there, or if you just want to be added to the mailing list, you're not currently on it, just please send an email to diehardchallenge@gmail.com. Also, if you are interested in being a co-organizer, contributing to future challenges, send us an email. We're happy to bring more people on. And that concludes the introduction. I look forward to spending the next 6.5 or so hours with all of you. Thank you.